Fourier series, first model A. Now first we know the some rules in this Fourier series. First is the periodic functions. Sin x, cos x are periodic functions of period is 2 pi. As we know from trigonometrics, sin x plus 2 pi and cos of x plus 2 pi means it is like this: first, second, third, fourth quadrant. Okay, sin x plus 2 pi, 2 pi means 360 degree, 360 degree plus x means it is again a first quadrant, angle is in first quadrant. Cos is also same, cos x plus 2 pi, 360 degree plus x again is a first quadrant. Sin x plus 2 pi is equal to sin x only, cos of x plus 2 pi equal to cos only. Is a first quadrant. First quadrant all are positive. Now is a Fourier series. The Fourier series is f of x is equal to a naught by 2 plus summation n is 1 to infinity n cos n pi n cos nx plus summation n is equal to 1 to infinity bn sin nx. This formula is most time using this model A. Okay, very important. Now, where a0, an, bn are all constant is called trigonometric series, and f of x is defined in the interval, the length is 2 pi, is in between c to c plus 2 pi. So how to find a0 and an and bn and substitute in this equation? Now a0 is 1 by pi integration of c to c plus 2 pi f of x dx, and an is equal to 1 upon pi integration of c to c plus 2 pi f of x into cos nx dx. bn is equal to 1 by pi integration of c to c plus 2 pi f of x into sin nx. The expressions for finding a0, an, bn are called Euler's formula. Rule: first one, integration of c to c plus 2 pi cos nx with respect to x is equal to, and integration of c to c plus 2 pi sin nx with respect to x, this is equal to, both answer is a 0, where n is a positive integer. Okay, second one, integration of c to c plus 2 pi cos mx into cos nx with respect to x, and this is equal to integration of c to c plus 2 pi sin mx into sin nx with respect to x, both are, and this one equal to, answer is a 0, where m and n are positive integers. Okay, both are positive integers, but m is not equal to n. Third point, integration of c to c plus 2 pi sin mx into cos nx with respect to x, and this is equal to, again value is a 0, where m and n are positive integers. The fourth one, integration of c to c plus 2 pi cos square nx with respect to x, and this, and integration of c to c plus 2 pi sin square nx with respect to x, both values are same, the value is pi. Take this one equal to pi, or second one, this is equal to pi, where n is positive integer. Useful formula. The first one is Bernoulli's generalized rule of integration by parts. The formula is integration of u phi with respect to x, and this is equal to u integration of phi with respect to x minus u dash integration of phi with respect to x 2 times plus u double dash integration of phi with respect to x minus sine and so on. And this is a Bernoulli's rule of integration by parts. The first one is a polynomial in x, and second one is a trigonometry function, exponential function, and first one is polynomial in x. So use this formula. Now see this formula: plus minus u dash u double dash, one time integration, two time integration, three time integration, one time with respect to x, two times, and three times with respect to x, and so on. Okay, next formula: integration of e raised to ax into cos bx with respect to x. This is a standard formula, is e raised to ax upon a square means this part plus b square, this part b square, into a cos bx plus b sine bx. Next one, integration of e raised to ax into sine bx with respect to x, e raised to ax a square plus b square into a sine bx minus b cos bx. So minus b cos bx means integration of sine is a minus cos. Okay. Next one is very important, this formula: sine n pi equal to 0. Sine n pi 180 degree, sine 0 and sine 180 degrees is 0. Okay, and cos n pi into minus 1 raised to n, n pi equal to minus 1 raised to n. Cos n pi equal to minus 1 raised to n means n is equal to 1, 2, 3. 180 degree, 360 degree is a plus minus, you will get 1. Minus 1 plus 1 minus 1, like this. Okay. Next one. Now cos of 2n into pi is equal to, one is a plus 1, another one is a cos of 2n plus 1 into pi is equal to minus 1. See, the 2n into pi is a plus 1, cos 2n plus 1 into pi equal to minus 1. So when is possible plus 1 and minus 1? N is, when plus 1 is, n is a even. This n is a even, and cos this n is a odd. You get n is even means plus 1, n is odd means is minus 1. This is a very, very important formula. So using this model, proof of Euler's formula. The given Fourier series f of x is equal to a0 by 2 plus summation n is 1 to infinity an cos nx plus summation 1 to infinity bn sin nx. So how to get a0, an and bn? Okay. Now integrate equation number 1, means this is equation number 1. Integrate equation number 1 with respect to x from c to c plus 2 pi. Okay, whole equation you integrate with respect to x. Integration of c to c plus 2 pi, this is f of x, and each term 1 2 3 terms, again applying c2 c plus 2 pi a naught by 2 with respect to x, plus I'll take summation outside, n is 1 to infinity and an is also outside constant an, integration of c to c plus 2 pi f of x cos nx with respect to x, plus summation n is equal to 1 to infinity bn integration of c to c plus 2 pi sine nx with respect to x. Okay, now using the basic formula in this given already, this part second term and term is a 0, and this is equal to a naught by, with respect to x, a naught by 2 constant outside c2 c plus 2 pi with respect to x. That means integration of 1 is a x, a naught by 2 x c2 c plus 2 pi, and this is equal to a naught by 2. Now first to apply upper limit c plus 2 pi minus lower limit c. Now c cancel, only remaining 2 pi, and 2 cancel, only remaining pi. Integration of c to c plus 2 pi f of x is equal to a naught pi, and therefore a naught is equal to cross multiply 1 by pi into integration of c to c plus 2 pi f of x, with respect to x, with respect to x, with respect to x. This is a naught. Now required an. Okay, again taking equation number 1, taking the expanded form of equation number 1 and multiplying by cos nx and integrating with respect to x from limit is c to c plus 2 pi. Okay, now expand this one, put n is equal to 1, a1 cos x, a2 cos 2x, like this, and same 1 to infinity, again n 1 to infinity, expand this series, applying integration both sides, integration of c to c plus 2 pi f of x with respect to x is equal to, multiplying by x into cos nx, I'll take with respect to x, and a naught by 2 constant outside, a naught by 2, integration of c to c plus 2 pi cos nx with respect to x, plus expand second term, n is equal to 1, a1 integration of c to c plus 2 pi cos nx, and n is equal to 1 means only cos x with respect to x. Now this series is continue, plus n is equal to a2, only second term, integration of c to c plus 2 pi cos nx, and n is equal to cos 2x with respect to x, plus so on, and n is equal to n plus an. Okay, this part plus an integration of c to c plus 2 pi and multiply by cos nx and one more cos nx. Okay, it is a cos square nx with respect to x, plus next is third term, put n is equal to 1 2 3 4. Okay, plus b1 integration of c to c plus 2 pi cos nx into sin x with respect to x, plus b2 integration of c to c plus 2 pi multiplied by cos nx into sine 2x with respect to x plus so on. Okay, now integration of c to c plus 2 pi, this is the left hand side, f of x into cos nx with respect to x is equal to, accept this term already given formulae, this part is 0 and this one is 0, 0, 0, all terms are 0 except this one, and an, and this one is already given in a rule only pi. Now therefore an is equal to 1 by pi, pi is a cross multiply, integration of c to c plus 2 pi f of x into cos nx with respect to x. This is second a naught. Now third one is bn. What is a bn? Similarly, multiplying expanded from equation number 1 again, but sin x you multiply whole equation and integrate with respect to x, integrating with respect to x. Now you get bn is equal to same procedure, only multiply by sin nx whole equation, same using same method. Bn is equal to 1 by pi integration of c to c plus 2 pi f of x into only change cos to sin nx with respect to x. This is third bn.